Hello everyone, my name is Jim Butler. I'm a church organ repair technician, and I'd like to talk a little bit today about Hammond Tonewheel generator run motors. As some of you out there may know, if you work on organs or if you own a Hammond organ, you may have run into that situation where the Tonewheel generator run motor fails or has failed with age. And the reason for that is because the original coils, these were the self-supported type, varnish dipped and fired type coil, and the gauge of the wire was very small. And so after decades and decades of deterioration of the varnishes and the enamels of the wire, eventually the acidity of that deterioration will eat through the wire, and then it no longer conducts current. And when that happens, the motor no longer has any electromotive force, and it can no longer operate. So I have three right here. These are typical of what a Hammond run motor would look like. Some have this ledge on it, most don't. This one I've already removed the protective band, but you can see these have the original wire. This is much what they look like when they come out of the organ. And so what I do is I disassemble them, I completely clean them, I discard the original field coils, and I rebuild these motors completely. And when I'm finished, they come out looking like this. It might help if I turn on a little light. This is what they look like. As you can see, you can see the lead wire from the new coils. Each coil looks like this. These I had them made by specifications that I provided, and these are custom-made coil forms. They made these forms to my specifications, wound them with the number of turns and turns per layer, and so on. The inductance is exactly what it was on the original coils. The only difference is that the gauge of wire on these, the magnet wire, is slightly larger, and I did that so that they will, through decades and decades of use, any breakdown that may happen, it'll be longer before the wire actually fails open. Also, because the wire gauge is slightly larger, the DC resistance of these coils is slightly lower. So the originals, if you measured them, a good healthy original run motor coil would have measured about 180 ohms. These are about 154 ohms, but that also has the result of slightly higher current. You've got the current limited by the inductive reactance of the coil, but the resistance of the coil, the DC resistance of the coil, also contributes some measure of limiting of the current. So the slightly larger magnet wire means that you've got slightly more current, and that results in a higher magnetic field, which means more torque at the generator. So that's a good thing. Again, each of these motors has two of these, and we have 4 ready to go here. These stickers say hammondrunmotors.com. That's a domain that I own, but I don't have the site up yet. Maybe by the time you see this video, I might have had a chance to put the site up. These motors, when I finish with them, they carry a 5-year warranty against failure of the coils. And I reason if they'll make it for 5 years, they should make it another 80 to 100 years, who knows, maybe more. But it's a requirement to have the warranty that the buyer register their product. Each of these has a tamper-evident seal with a unique number on it, and I do that so that I have to know if I get a call to replace one of these that may have gone bad or something. As unlikely as I expect that to be, still I put my money where my mouth is, but I need to know that nobody went into the motor and tampered with it and caused it to fail. So that's what that is. As long as that seal isn't broken, the one I showed you here in the back, as long as that seal isn't broken, cut, or anything like that, I will honor any warranties within 5 years of purchase. I've got more of these in boxes over here ready to go. Here's 2 ready to go to a dealer. I've got others in some of these boxes. Each of them ready to go to different people. Over here, this is an M series generator, probably an M3, maybe an M100. Anyway, whichever one, I forget what I pulled it from, but this is one of those run motors that I rebuilt, and I'm just running it in to, just to see how it does. I'm going to run it for probably about a week. As you can see here on the meter, it's drawing 260 milliamps. That calculates down to about 30 watts of power. Yeah, 260 milliamps is about 30 watts of power, which is about right. It's been on now for about 2.5 hours, and it's barely warm to the touch. I mean, that motor, you'd hardly notice it's been on any time at all. But you can see here, the older coils, if I put this much force on it, it would have quit by now. But these have higher torque, and so if your generator has a little bit of drag to it, you won't have to worry as much about it running out of torque, bogging down and making the motor quit. These motors are quite strong. As you can see, I've got the cover off of the vibrato scanner, so you can see the rotor inside the scanner actually moving. The light above us, it's a track light. It has a flicker to it, and so the beating between that light flicker and this telephone's refresh, the camera refresh of the telephone, is making it where it seems like this is turning slower than it is. It may turn out that way in the video. I don't know if you can see that, but certainly on my screen it looks that way. But this is going every bit of, this is 1200 RPM, which is what it should be. So just in case that's a question or concern, it's just the camera. But these motors are doing very, very well. If you need one, if you have a burned out or failed run motor and you need one replaced, you can call me. My number is 334-701-7771. Again, that number is 334-701-7771. My name is Jim Butler, and I look forward to your call. Thank you.